Hello YouTube family. Most of you know that we bought a 5th axis Niken along with a VF4SS. We bought them used, they came together, and that's our intro into 5th axis parts. Now the Niken runs 90 degrees, basically 90 degrees rotated than most of the Haas 5th axis. So it's been kind of a learning curve for us because there's a lot less information out there. So we're going to be putting out a video series about how we set everything up on ours, but this is just a small beginning part. The platter of the Niken doesn't have holes that match up with more than two. It doesn't have slots that match up with more than two of these mounting holes. So that's how we've been mounting this rock lock base, and then the 5th axis vise mounts to that. So we need a better way. That's been fine for aluminum and stuff. We're going to start doing some steels and stainless, and I want to make sure we got a solid foundation. So what my original thought was to build a plate underneath here that would interface between the platter and the 5th axis rock lock base, but that would make me lose about an inch of space between the two Z height, and I don't really want to do that. So like I said, since this machine's used, somebody previously had drilled holes into the platter to mount, I don't know what they mounted on there, to be honest, but since there's already, if it was new I probably wouldn't do this, but since there's already holes, I'm gonna go ahead and mount this on the 5th axis and make sure that basically thread mill this mounting placements and probably one of these gauge pin holes into the platter of the Niken. That way I'll be able to not lose my Z height and bolt this thing directly down to the platter of the 5th axis and not have any movement issues, and hopefully have alignment bits. So long story short of this video is just what I'm going to do is I want to eyeball everything in the actual machine itself, placement, to make sure I'm going to miss the screw holes that are already there and all that stuff. So I'm going to just 3D print out a little template that I can throw on top of it and make sure everything's going to be lined up. So first thing we do is create a construction plane on the bottom of the 5th axis rock lock base, and then we are going to create a sketch on top of that. I'll project out the 5th axis, the bottom of this 5th axis rock lock base, and that's mostly it. I just need to extrude Q and then extrude out. We're going to go negative. I think we're only going to need about a 20 thou thickness or so to print out. We'll make a new body out of that. We'll hide the original body, and that gives me a 20 thou thick little plate that I'm going to print out on the 3D printer, and we'll take it to the machine and check our alignment, make sure what I'm thinking is going to work and that we're not going to have any issues with the holes that have already been drilled there. So onto the machine next. Okay, so here are the holes that are already in here in the vise from the previous owner, and like I said, these I can't match more than 2 holes up at a time, no matter how I rotate this using the T-slots. So this is a little template that I 3D printed, and I noticed that these actually will match up with these 2 holes here. And I've gone ahead and mounted the vise and tested center and made sure that I could actually center it in the holes that are here, and I can. So while the vise was on here, I kind of got everything centered, and then I circled in these 2 little holes for a sanity check later when I put in the next 2 holes. These turn out to be M10s, so I'm going to go ahead and tap these 2 holes M10. Everything's zeroed upon the 0 axis here, so I should be able to, oh, and then I squared the vise this way, so I should know pretty much where these holes are and where the center is, and that should give me an idea of where to put these two holes. And once I do that, if everything goes well, we should be able to bolt it down to here with no problems. So that's what we're going to try to do. Okay, so these are the two holes that are already there. We've squared this edge up and made this our Z0 in the machine. I mean our A0. So what we need to do is basically just drill these two holes, and I think we should be good. First thing I'm going to do with this is set it to inches. I'm going to go crazy. And we're going to copy this sketch just because I want to change the hole size on this but not affect the ones from before. So let's edit this, break the link, and we're going to drill this to a R9, about 71% thread engagement, and that is a .339. This one as well, 0.339. And that's going to be it. We want the I measured the depth of the holes that were already there, about 875, so we're going to make that our maximum depth here. So the next step is to go into manufacture, I think. So let's go ahead and create a setup. This is going to be our 0. Alright, and we'll just go to set the point. How about that? And set our Z. Alright, so this is how it's going to be set up. We're not going to use the 5th axis coordinate system. We're just going to copy the XY0 to the G54 offset, probe the top of that, and start going from there. So this is how we're going to set up. Alright, so first thing here would be to drill. And let's see here, we're going to do these two holes and select a drill. And what's going on here? Our R9, I don't know what steel this is. We're just going to take it slow and, you know, make the holes we need. I've got it set for M2, but it should be good. We're going to go ahead and chip break, and I think we're gonna go, yeah, I think we're not. I think we'll just go here, and alright, we're gonna get a little bit below there. Because I want to be able to thread mill as deep as possible, but I don't want to cut in deeper than they already have because I'm not sure what's actually below the platter there. So we'll start with that. So I've already cut M10 threads before with a thread mill, so I should have that already set up. Let's see here, 2D threads, select the tool. Got it moved into here already. Steel. Okay, so now let's select our faces here. Thread pitch diameter offset. That should actually be set to something. Let me see. Template. Metric thread mill. Let's see if I've got it stored here. Okay. So let's see what this offset is. Okay, so I have a pitch diameter offset. So I went ahead and created a template of them. I have the tools, but that doesn't give you the pitch diameter offset. So I created a template with my metric ones that I've done, thread milling, and my regular standard American. So usually what I do is I'll take this pitch diameter offset and make it a little bit lower just to make sure I can sneak up on the hole, especially if it's super important like this. Yeah, it's okay. And as you can see, if you edit the tool here, I put my information here. I bought this from Carbide Tool Source. It's their product ID is I26, and I always use them tool number. Well, it's not set. Use tool number 10 for my taps. So this should give me a good starting position. Like I said, I'm going to go ahead and take this down to, I don't know, we'll just change it to like 60 for now. Okay, oops, select our holes. And we'll start with one hole because I want to make sure I get this pretty exact, considering this is my platter on my 5th axis. And I got a center drill here. We'll go ahead and do that. Select my center drill holes, and like I said, I use templates for a lot of things, so that I don't have to think too much. All right, so first thing we're going to do is center drill, and we're going to take out this one and just use this one. So I'll go ahead and delete that now. So we'll just simulate for fun, and that's not drawn like it should be, but that's okay. Okay, so I think we're going to be good there. Let me go ahead and post this code, and we'll take it out to the machine. Alright, so what I'm going to do is move the 5th axis to X0 and Y0 on the G57 coordinate system, which is my the X0, Y0 of my 5th axis offset. So we're going to go ahead and do that. Alright, now I don't want my offset, come over here, Jeremy. So I don't want to modify this offset or anything, but I want G54 to match G57 basically. So I'm going to part 0 set on my X here and my Y, so those should now be the same as my G57. And then we're going to go ahead and probe the top of the vise, the platter here. I got Jeremy shooting video while I'm doing the work here. Okay, now we're going to go to probing on G54. We're going to do a 11, I believe, for a single surface. And we're going to probe the Z, and we'll be good to go. So we're going to probe the Z. So now the XYZ will be set to the very top of the platter and the same 0 that the Nikon has, which basically how I set the XY for the Nikon is I just probe this bore. This bore gives me my XY. Okay, so the first thing I'm going to do is is center drill to make sure that I'm close to where I think I need to be before I go drilling anything. Let's get out of there. Let's center drill. It looks good enough, so we're going to go ahead and load up the second part of the program, which is drilling and then thread milling. So I'm only going to thread mill one hole because I'm pretty sure it's not going to be right. I want to make sure I got clearance here. Okay, so I expect this to be undersized because I made a modification just to make sure we weren't going to be oversized. Okay, so that's the actual bolt that's going to go in there. Does not fit. I'm going to add a couple of nice chamfers to those holes, and then I'm probably going to just pause the video until I get the holes to the right diameter. Alright, I got the thread mill finished out, and I should trust my settings because I brought it back to the actual save settings by the time I was done, and it's a perfect fit. So here is the goes, the no-go does not. Alright, so we had to redial the X back in. That's pretty close. Alright, so then I'm going to go ahead and set my A rotation 0. At this point, these are the two screw holes that were already here on this side. These are the two I did. It's tightened down. It's perfectly center. I think we're good to go. Next is mounting the vise. Okay, and the vise is mounted back on the machine. Everything is set up, and yeah, you can see that I'm learning the 5th axis still. I've done a little damage here, but I hope to replace those soon and not have to worry about it. But I want to get more experience. I mean, they work perfectly fine, but yeah. All right, thanks D&J family. Thanks for watching.